Hi guys. Okay, this is question 3 for HL, 8 for SL. Now this is a nice, it's a nice question. Nice as in well designed, kind of typical sequences and series question where they combine an arithmetic sequence and a geometric sequence. So Charlie and Daniela each began a fitness program. On day 1, they both ran 500 meters. On each subsequent day, Charlie ran 100 meters more than the previous day, whereas Daniela increased her distance by 2% of the distance she ran the previous day. So let's break it up into the two different people first. Okay, we have Charlie. Now, Charlie is, it's nice to think about this yourselves, guys. Which is it, an arithmetic or a geometric sequence? Well, Charlie's is an arithmetic sequence because he's increasing it by 100 each day. So Charlie's U of n is U1, well, U1 plus m minus 1 d. And his U1 is 500 because he ran 500 the first day. His n is, well, his n is just his n, and his d is 100 because that's the difference. He's adding 100 each day. So that's Charlie's U of n. Daniela's is a geometric sequence, and her U of n is U1 or to the n minus 1. Her U of 1 is also 500. Her OR, which is her common ratio is, because it's 2%, so it's this times 1.02. So just be careful. She's increasing it by 2%, so you got to multiply by 1.02. And this is to the power of n minus 1. So A part I is equal to, well, it's going to be just this. It's going to be U of 20. So U of 20 is equal to, and I'd literally put in 500 plus 20 minus 1 is 19. 19 times 100, guys, I can do this in my head. I was going to take out my calculator. I don't even need it. So it's 1900 plus 500, which is 2400. Easy. Daniela's U of 20. So this is AII. Her U of 20 is 500 times 1.02 to the power 20 minus 1, which is 19. This, yes, I absolutely, definitely want my calculator for. It's 500 times 1.02 to the power of, no, to the power of 19, which is 728.406. 728.406. Now I'm actually looking at that and thinking, that seems like she's running a lot less than him. But maybe, and this is coming to the next question, on day n of the fitness program, Daniela runs more than Charlie for the first time. So she starts running a lot less. Well, they both start with 500, but she's increasing hers very, very slowly, whereas he's increasing his like very quickly. He's adding on 100 each time, which seems like a lot. Yeah, so it does kind of make sense that he'd be a lot more after this much time. But it's a bit like the power of compound interest. She is going to suddenly run more than him. So how are we going to do it? Well, we basically need to find out when will this function equal this function. So actually, let me do it down here, guys, just so I have enough space to write this equation. So for what n will 500 plus n minus 1 times 100 when will this equal this? 500 times 1.02 to the n minus 1. So when will this equal this? Now, a nice way to do this, guys, I think, is to actually graph them both, so you can actually get a good image of what's happening. So this guy is 500 plus, remember to use x minus 1 times 100. That is his graph. Now it doesn't look like anything, because remember, he's starting at 500. So when n is 1, he's going to actually be at 500. So let me just change the zoom a bit here. I'll try the zoom fit. Okay, yeah, that looks better. Okay. Now, I'm going to draw her graph. So her graph is going to be 500 times 1.02 to the power of, it's x minus 1, which is this. Okay, now you'll see so hang on, that can't be perfectly right. Okay, yeah, sorry. So they do actually, yeah, because it's at 1. At day 1, they're the same. So 1 is the first day, and they're both at 500. Yeah, sorry, that doesn't make sense. So it says on day N of the fitness program, Daniela runs more than Charlie for the first time. So on the first day, they're the same. But what's actually happening, if I zoom out here, watch this menu, zoom out. If I zoom out, we'll see her, look, this is her training suddenly starts to get really, really, really rapid. And that's what I'm talking about, compound interest. So right there, that's when they run the exact same. So it'll be the next N, which is the first day where she runs a bit more. Okay, let me find that point. Menu, analyze graph, intersection, this and this, right? So it's 184.22, and it's the x coordinate I'm concerned with, because that's the day. So n is equal to 184.22. So n equals 184.22. But it says on day n, there is no day 184.22. So what's the first n where she runs more than him? Well, it's going to be the next day. So therefore n equals 185. Okay, nice question, as I said, guys. Nice kind of real life example. Mixes the geometric sequences and the arithmetic sequences, and you need to have a good hold of your calculator. Make sure you know what you're doing, drawing the graphs and everything. You could have solved this question with NSolve if you want, but just be careful, because they would give you one solution would have been 1. That would be the first solution, so you got to make sure you find the solution that's later on. Okay, I'll see you for the next question.